What can rocks tell us about the history of life on Earth? How do scientists know when species evolved or became extinct? In this article, you will learn about different types of evidence scientists collect and analyze in order to determine when something has occurred in the distant past. Scientists can organize this evidence into timelines that show the history of life on Earth. Relative dating of rocks and fossils. Scientists study sedimentary rock layers to gather evidence about Earth's history. The diagram shows how sedimentary rock layers are created slowly over time. Sediment, such as mud, ash, or sand, combine to form a layer. Later, another layer settles on top of that first layer, and so on. Each layer in a sedimentary rock formation has been there for less time than the layer under it. So, in general, the lower we go in layers of sedimentary rock, the longer ago the rocks were formed from sediment. Step 1. Sediment and water sink to the bottom, sedimentation. Step 2. New layers pile on top and press down on the older layers, compaction. Step 3. More sediment presses down and pushes water out of the layers. Step 4. Over time, salt crystals seal the layers together, creating sedimentary rock, cementation. New sedimentary rock is always deposited on top of existing rock layers. Therefore, deeper layers of rock are older than layers closer to the surface. This principle is called superposition. The Grand Canyon has many great examples of sedimentary rock layers. The Grand Canyon. Relative dating. Fossils are actually parts of ancient organisms or their imprints that are preserved in rocks or minerals. Relative dating can be used as evidence when determining the age of fossils. Scientists can determine the relative age of a fossil by comparing the layers of rock above and below the fossil. For example, in the diagram that follows, an arrow points to a layer of plant and reptile fossils. A fossil found in this plant and reptile fossil layer would be older than the vertebrate animal tracks found above it. A fossil found in this plant and reptile fossil layer would be younger than the trilobite fossils that can be seen in a layer below it. In general, this rule can be used. Fossils found in higher layers are younger than fossils found in lower layers. Rock layers with fossils. Geologic time. Trilobite fossils. Sometimes the method of relative dating does not work, either because the layers were not deposited horizontally to begin with, or because they have been overturned. If that is the case, scientists can use another method of dating called numerical dating. Stop and check. Choose another fossil layer from the diagram. What fossil layers are older than this layer? What fossil layers are younger than this layer? Numerical dating. Scientists also use a technique called numerical dating, or atomic dating, as evidence to determine the age of rocks or fossils. Very old rocks can be dated using volcanic material. By dating volcanic ash layers both above and below a fossil-bearing layer, as shown in the diagram, you can determine older than X but younger than Y dates for the fossils. Sedimentary rocks less than 50,000 years old can be dated by analyzing the atoms present in the rock. This technology can determine, within a certain range, the actual age of the rocks in a fossil bed. Once scientists know the age of a few rock layers, they can use relative dating to estimate the ages of others. This process is outlined in the diagram. Relative dating. Younger, older. Numerical dating. 495 million years ago, 510 million years ago. Dating of volcanic ash. The history of life on Earth. Based on rock and fossil evidence, scientists estimate that life began on Earth at least 3,500 million years ago, and it has been changing ever since. Evidence shows that the earliest forms of living things on Earth were simple, single-celled organisms. Rock and fossil evidence also shows us that much later in Earth's history, multicellular organisms could be found on the planet. These multicellular organisms did not suddenly appear out of nowhere. Fossil evidence shows that these multicellular organisms evolved from the single-celled organisms that were already there. Evolution is a change in the characteristics of a group of living things over time. Over many generations, this can lead to the formation of new species. The earliest forms of life on Earth were unicellular organisms. Later in Earth's history, multicellular organisms evolved from unicellular organisms. The history of life also includes the disappearance of species. Extinction is the complete disappearance of a species from Earth. Once a species is extinct, it cannot return. Throughout Earth's history, many species have gone extinct. When a mass extinction occurs, a large amount of species go extinct in a relatively short geological period. Rock and fossil evidence shows that dinosaurs went extinct around 66 million years ago.